How to calculate the size and power requirements of a solar system infrastructure, including the battery storage system. Start with obtaining the annual or monthly energy consumption data. It will look something like this. It would have your account number, the interval time, consumption in kilowatt hours, peak demand, and sometimes power factor is available. This data is based on a daily energy consumption for a period of 1 month. The next task is to calculate the average daily consumption. I live in Vancouver, British Columbia in Canada, and using the Canadian Weather Network data, I can find out this figure. I know that for Vancouver, the average daily sunlight hours is 4. So using these 4 hours, we can capture the energy for our daily use. This template automatically calculates the power requirements for you. So our power requirements is 2.1 kilowatt. Next, you have to calculate the size and rating of the battery storage system. Why do you need a battery? Well, unless you're going to be there to capture and to use all of that energy within a 4-hour window, you're going to need to store it somewhere. This is why we need a battery. There's 2 types of batteries, lead acid and lithium. They have 2 characteristics about them, the inefficiency ratio and depth of discharge. Depth of discharge is the actual energy taken out of the battery compared to the nominal rating, expressed as a percentage or in ampere hours. So for instance, depth of discharge of 80% means that we have to leave 20% of energy in the tank or in the battery before we have to recharge it up again. The inefficiency ratio is just the inefficiency of the actual battery. We need to store more than required for us to actually use whatever energy we need. Let's calculate the energy rating of a lead acid battery. Lead acid batteries usually have a lower depth of discharge. They're an older type of technology and they're also much more affordable. Usually they have a depth of discharge anywhere from 50 to 60%. Let's choose 50. They also have a higher inefficiency ratio, anywhere from 20 to 25%. So let's choose 25. This would be our energy rating in kilowatt hour units, roughly 5.6 kilowatt hours. However, note that the actual energy rating of a battery that you can purchase in a store is in ampere hours. They also have an operating voltage. Usually the most common ones is 12 or 24. Let's choose 24. So this would be the actual rating in terms of ampere hours of the battery. This is what you would look for, or this range, anywhere from 230 to 250 or 260. You will look for this type of rating in a store, your dealer, or your contractor, whoever you would purchase the battery from. Let's go through an example of calculating the lithium energy rating. Now, like I mentioned, they have much higher depth of discharge compared to lead acid. It also makes them more costly. However, it reduces the size and increases the lifespan of the battery. Usually, they have a depth of discharge anywhere from 90 to 80%. Let's choose 80. The inefficiency percentage is also lower for this type of battery, anywhere from 5 to 10%. Let's choose 10%. This is the energy rating in kilowatt hour units, roughly 2.9 kilowatt hours. Choose the same operating voltage, and our energy rating is much lower, and most likely the size of the lithium battery is going to be about half the size of the lead acid battery. And here we can see that our energy requirements, depending on the battery, is either one of these 2. In a summary, we started out with energy consumption that we obtained from our utility account. Then we calculated the average daily energy consumption, which was 8.3. Then, using the data weather network in your geographical location, we found the sunlight hours on a daily basis, again for the geographical location that you're in. Then we calculated the power requirements, which was 2.1, roughly 2.1 to 2.5 kilowatt. This is the size of our entire solar panel system. And then we calculated the battery storage needs depending on the type of battery we chose. This concludes calculating the solar panel size and power requirements, including the battery storage system.